Hi, my name is Rohit Kumar. Today we will discuss how to deal with missing values and outliers. Before addressing missing values or outlier, we have to analyze the variables of the dataset, set some hypotheses, and then remove any unnecessary variable from the dataset that do not affect the dependent variable y. Additionally, we have to gain some knowledge of the industry related to the dataset. For example, in our screen, the dataset you see is from the healthcare industry. In this dataset, our dependent variable y is the outcome column where false stand for patient with no diabetes and true stand for patient with diabetes, while the rest of the columns are our x variables. Let's set some hypotheses based on the knowledge in the healthcare industry. Pregnancy can be 0 but cannot be NA. The column price of insulin is not relevant to the predict outcome. Therefore, we can remove this column. In the age column, you can see the outlier. Age cannot be more than 100 years. And a test for diabetes is not useful for a 2-year-old child. The price of insulin cannot be negative. So we have to analyze the data first and then remove some extra columns. After that, we remove or replace the missing value and outliers. Our first method is removing the column. In the screen, you can see the zero value in the most of the cell in the diabetes pedigree function column. In this scenario, we can remove this column because if we replace this with the mean value, then the machine may predict the wrong outcome. So it's better to remove the column. If 75% of the data have missing or none values, as we did for the column, the same thing we can do with rows. For example, in the screen, you can see the row having most of the value are 0. So we can remove those entry where 75% of the data are missing or none values. Let's replace the missing or none value with the mean values. In the column of glucose, there is a value 0. Let assume if glucose cannot be 0, then we assume this as missing value or none value, and we can replace this with the mean value, which is approx 119. We can also replace by category wise on y variable. Why we are doing this? Because this value contributing in the false outcome only. So in this case, we can replace this with the mean value of the same category, that is 80. It is your choice to replace the value with the mean value of the whole column or by categorizing the y variable. We can also replace with the median value. I think you already know how to find the median value in the column. Let's revise again. In this chart, there is a column of pregnancy. Let's sort this column by smallest to largest, then find a mid value, that is 5. So we can replace the NA value with 5. In this column, value 0 cannot be missing value because pregnancy can be 0. Let's replace the NA value by categorizing the y variable. In this case, the mid value will be 6. Again, it's up to you which way you think is good. The next method to handle the missing value is the extension of the column into a new column. Let's assume our outcome depend on the patient with pregnancy or not having a pregnancy. It does not matter how many times pregnancy happen. In this case, we can simply create a new column with the value of true or false. True for pregnancy and false for not pregnancy. Our new column depend on the old column, where if the value is 0 in the old column, then we can set false in our new column. If the value is any positive number in the old column, then we can set true in the new column. Let's replace the NA value with the mode value. The mode value is that value which come many times in the data. In this case, our mode value is 1 and we can replace the NA value with 1. We also replace the mode value in the same category of the y variable. We can handle the outlier the same as we handle the missing value. That's all in this video. We discuss the mean, mode and median to replace the missing or none value or the outlier. Thanks for the watching this video.